Hi, in this lesson, we'll introduce recursion. Let's get started. Back in Unit 4, we introduced loops as an iteration tool. As I'm sure you have seen by now, they're very useful. For example, if we wanted to sum the numbers from 0 to 10, we can write a quick loop to accomplish this. In this lesson, we are going to introduce a new iteration tool. Introducing recursion. Recursion is an iterative process where a method calls itself. We use recursion to break a complex problem down into a slightly simpler version. We continue to do this until we get to a problem that is so small it is easy to solve. Let's take a look at our problem from earlier. Let's start by looking at this problem mathematically. What would a function to sum the numbers to 10 look like? We could write this out with every number starting at 10 and continuing to 0. We can actually take this part of the equation and rewrite it as the function sum9. So our original formula can be rewritten as sum10 equals 10 plus sum9. We can keep doing this all the way down to 0. Each time through, our problem gets a little simpler. When we get to 0, our problem becomes really simple. Sum of 0 is just 0. When we get to the point where we can't simplify our problem anymore, we say that problem is our base case. In this example, our base case is sum of 0 equals 0. Generically, we can represent all of our other numbers with the formula sum of n equals n plus sum of n minus 1. Let's take a look at this in Java. If we wanted to create the sum function we saw above, we know that it needs to take a number as an input and return a solution. Let's start with our easiest problem. We said that if the input number is 0, our solution is 0. This is our base case. We can state this with a simple conditional statement. We said if we weren't at our base case, then our generic formula would be n plus sum of n minus 1. We can use that as our return statement when we are not in our base case. This is now our recursive function. Let's walk through the recursion process. This line represents our first call to our recursive function by calling sum5. Inside our function, n does not equal 0, so we do not return 0. Instead, we want to return n, which is 5, plus sum of 4. Before we can return that statement, we have to resolve sum of 4, so we call that function. Now we are in the function for n equals 4. Once again, n does not equal 0, so we skip the first return statement. Each time we call the sum function, we generate a new iteration of the sum method with its own set of local variables and formal parameters. We now return 4 plus sum of 3. Once again, we need to resolve sum of 3 before we can return 4 plus sum of 3. In our next call, n is still not 0, so we return 3 plus sum of 2. Notice how the parameter value for n tracks our progress through our loop, similar to how a loop control variable captures the progress of a loop. This process continues as we get deeper and deeper into our stack. Remember, at this point, we have not returned anything. Each of our return statements has called another function, and until we get the return value for that function, we can't return for the previous function. Essentially, sum of 5 is waiting for sum of 4, which is waiting for sum of 3, etc. We finally get to n equals 0, which is our base case. We can now return 0 back to the sum of 1 function. Remember, the sum of 1 function is returning 1 plus sum of 0. This process continues as each return statement now has the information it needs to return the next value. One by one, our returns get completed and our methods get closed out. Each time the value of our sum grows. Finally, we get to the original sum method call and can return the solution back to the call in the main method to be printed out. Let's recap this example. Remember, each time we call our recursive method, its own set of local variables are created. When we look back, we can see that the sum method was called a total of 6 times. Our progress was tracked by the formal parameter as we went through the different calls. In the end, we are able to accomplish the same task as our for loop that we saw earlier. Let's look at a problem where we want to sum all the values in an array up to a specific index. We can use this process to kick off our recursion. Our solution code is similar to what we used last time. The difference here is that we are passing both the array and the index value in our method signature. So how many times will we call the SumArray method? Let's take a look. Our first call is with index equals 4, length minus 1, which represents the last element in our array. Each time through, we are calling one index lower using the recursive call. This process continues. Notice we haven't actually added anything up yet, but we continue to make our recursive call until we get to the base case. We continue to recursively call. Even though we're at 0, we still have one more recursive call to make because we have not yet reached the base case. Finally, once our index is less than 0, we have reached our base case. We call back now, adding up as we go. Eventually, we get back to our call from the main method and can print out the number 15. Let's take a look at an AP-style question. Oftentimes, you will be given a question and asked to understand the recursive process and can demonstrate this by either understanding how many recursive calls are made or what the output might be. In this case, we want to trace the recursive call to understand the output. Our first call will be the originating call. The method starts by printing 20. Then, since x is greater than y, it makes a recursive call with x equals 19 and y equals 15. Our second call looks similar. The process continues until x equals 15 and y equals 15. At this point, x is no longer greater than y, so we don't make a recursive call and our methods complete normally. Our correct answer in this case is option B. A recursive method is a method that calls itself. We use recursion to help take a complex problem and make it simpler each time we call it. Once we get to a point where our problem cannot get any simpler, we are said to have reached the base case. Problems that can be solved with recursion can also be solved with loops. Now that you've learned about recursion, let's get some practice in the editor.